Then we will go on to the fault exceptions. So these are the faults mainly occurring: bus fault, memory management fault, usage fault, hard fault. The bus fault will be generated when an error response is received during the transfer on the HB. Whenever it is receiving an error response in the HB interface due to some data transfer, bus fault will occur. So what all conditions can create error response? That is what is written here, right? So bus fault will occur when an error response is received in AHP. So what are the reason for that? First one is attempt to access an invalid memory region. You are trying to read from a memory location which is outside your processor memory or any other memory. So it will create a bus fault error, or it will generate a error response. Similarly, if the device is not ready to accept a data transfer, say for example, you are trying to access the SD-RAM, but you have not initialized the starting location. You need to initialize the starting location with the SD-RAM controller. Then only you can start reading or writing into the location. But you have not done that. So data will not be you cannot read the data. Data will not be available. So this is a second condition of error response generation. Third condition is you are trying to carry out a transfer, but the transfer data size is not supported in the target device. Say for example, in your case, the controller is 32-bit controller, but if we are trying to access above that, and in certain cases, byte access is not granted. So if you are trying to perform that byte access in certain peripherals, again error response will be generated. And the last one is the device is not able to accept the transfer because of certain conditions. For example, you have programmed the device to send the data only in privileged access level. But let us take you are in user access level. You have programmed the device in order to give the data only in privileged access level, but you are trying to access it in user access level. Again, a response will be generated. So in any of these conditions, error response will be generated. So bus fault will occur, because all these are related with the bus interface. You are trying to deal with some data access through the bus, right? So it can happen in these two stages. It can occur in instruction fetch stage, that is known as prefetch abort. Whenever prefetch abort is occurring, bus fault can occur. Then in data read write state, that is known as data abort, because it is not able to access the data due to the conditions which we have seen before. So in these two stages, bus fault can occur, right? Then in addition to these conditions, there are few more conditions in which bus fault can occur. First one, during the stack push operation, when the interrupt is started. When the interrupt is started, the stack push operation will be done automatically. We are not doing anything, it will be done automatically. But if any error has occurred during that process, that is known as stacking error, then bus fault will occur. Similarly, at the end of the interrupt processing, you will be the stack pop operation will be performed automatically. But again, if any error has occurred during the pop operation, that is known as unstacking error, again bus fault will occur. Then finally, you are trying to read an interrupt vector address when the processor is executing an ISR, that is known as vector fetch error. Again, this bus fault will occur. In addition to that, hard fault also will be occurring. So these are the three special conditions when bus fault can occur. In addition to whatever error response we have seen in the previous slide. Right. So if bus fault is occurring and if no other interrupt or ISR is being executed in the processor, what will happen? Bus fault handler will be executed. Bus fault has occurred, and if no other exceptions are or ISR is executed in the processor, bus fault handler will be executed. Right. But if bus fault handler is not enabled, or when the bus fault is occurring, something else is running on the processor. If the bus fault is not enabled due to some mistake in the program, or if something else is being executed in the processor, then what will happen? Hard fault handler will be executed. So hard fault handler will be executed whenever a handler is not enabled, or if handler is not able to execute due to some other reasons. Whatever fault handler it is. If it is not enabled or if it is not able to execute, then hard fault handler will be executed. So how will you enable the bus fault handler? You are having a bit known as bus fault enable bit in the system handler control and state register, SHCS. So in this handler control register, you are having a bit known as bus fault enable bit. If this bit is set, then only the bus fault handler will be enabled. By mistake, if it is not set, then hard fault will be generated. Right? And one more thing you need to keep in mind, before enabling the handler, you need to make sure that bus fault handler starting address is present in the vector table. Normally, by default in the vector table it will be there. But if you are mapping that to some other location, you need to verify that that address is present in the vector table. Right? So after giving the starting address, then only you should enable the fault handler. Right? So these are the bits present in the status register of bus fault. Bus fault status register. So whenever stacking error is there, this bit will be set. This will be set due to unstacking error. Then imprecise and precise fault is there, that we will see. Then if instruction access violation is there, this bit will be set. Then one more bit here you can see, that is known as BFAR valid. What do you mean by that bit? BFAR valid. BFAR means bus fault address register valid. This bit is set when it is possible to read the memory location that caused the fault. One bus fault has occurred in a particular instruction location. So if the processor is able to read the actual address where bus fault has occurred, if it is able to read that, then BFAR valid will be set. That means bus fault address register valid will be set. What does it mean? That means that there is a register known as bus fault address register. In that register, your address where the bus fault has occurred will be stored. So if the processor is able to access the actual location where the bus fault has occurred, that address will be present in a register known as bus fault address register. So whatever value is there in this bus fault register is really valid, then this bit will be set. Then what do you mean by precise fault and imprecise fault? Right. So what do you mean by precise fault? Precise fault is a fault which is caused by last completed operation. If a fault is occurred as a result of the execution of the just previous instruction. For example, memory read is precise because memory read will be completed when it receives the data completely. You are trying to read the memory, that operation will be completed when it is receiving the data, right? So if some fault has occurred in the memory read, that is classified as precise fault. It has caused due to the last completed operation. But an imprecise fault, it is a fault caused due to already completed operation. It might has occurred few cycles before. It is not a previous instruction. It might have completed few cycles before. For example, buffered write. So in what do you mean by buffered write? You will start the writing operation, then that buffering will be taking place by its own, but the processor will be doing something else. There will be a write buffer which will perform the writing operation in the buffer, and the processor can do something else. So if some error has occurred during the buffered write operation before getting completed, that is classified as imprecise bus fault, right? So these two bits are also present in the bus fault status register. So these two are related with the data access. This is related with the instruction access. Then next one is known as memory management fault. So from the name itself, you will get some idea. It is something related to memory management. Bus fault means it is something related to bus. In the bus, what you are transferring? Data or instruction. So it is something related with data transfer or instruction transfer. Memory management means it is something related with memory management, right? So memory management fault will be occurring when we are trying to violate the MPU rules. For example, you are trying to execute code from a non-executable memory location. That is one example. And if you are having MPU, you are trying to read from a memory location which is logged by MPU, memory protection unit. So these are the two conditions where memory management fault can occur. You are trying to execute a code present in a non-executable memory location, or you are trying to access a memory location which is logged by MPU. Then these are some of the common MPU faults. That is what we have told. Access to memory region which is not defined by MPU. Writing to read only memory location. Last one is we are trying to read from a memory region in user state, but it is only defined as privileged access only. So in these three conditions, MPU fault or the memory management fault will be occurring. Then, as we have told, if the processor is already running another exception handler, or if it is not enabled, hard default handler will be executed. And in the previous case, one more thing was there. Here, if the bus fault is occurring while an hard default handler is executing, what will happen? Bus fault has occurred while executing a hard default handler. What will happen? Core will go to lockup state. It don't know what to do. Similarly, in this case also, if this same fault is occurring while executing a hard default handler or NMI handler, again processor will go to lockup state. It don't know what to do. Then how will you enable the memory management fault? Again, memory fault mem fault enable bit is there in the same register SHCS system handler control and state register. It is used for enabling the memory management fault handler. And again, we have told before enabling the fault handler, you should check whether the starting address is specified in the vector table. So these are the memory management fault bits. Memory management, that stacking error and stacking error. This is available here also, right? Because you are while stacking or unstacking, you may be trying to write into a location which is protected by MPU. So this will happen, stacking or unstacking error. Then memory management address register valid. Previously we have seen bus fault address register valid. Here it is memory management address register valid. What does it mean? When the processor is able to detect or determine which address has caused this fault, then this bit will be set and the address will be available in MMIR, Memory Management Address Register. Then if data access violation is there or instruction access violation is there, these bits will be set. Because since it is related with the memory, again data access and instruction access problem will be there. Right. When it will arise, again the same thing. You are reading from a memory location, it is logged by MPU for getting data. So data access violation will be there. Similarly, you are reading from a memory location which is logged by MPU, but you have written an instruction there. Again, instruction access violation will be there. Then the next one is usage fault. So from the name, you will get some idea. It is related with the usage of certain instructions and few other conditions. First one is when you are trying to execute some undefined instruction, usage fault will occur. What do you mean by undefined? So instructions which are not there in current instruction set, but it is present in some other version. In this version it is not there, but in another version it is there. That is known as undefined instructions. So in Cortex M3, if undefined instruction is occurred, usage fault will be occurring. But in ARM7, it will move on to a mode known as undefined mode. Right. Then when you are trying to execute a coprocessor instruction, again usage fault will be occurring. Then when you are trying to switch to ARM mode of operation, ARM state, again usage fault will occur. Then the fourth condition is invalid interrupt return. Means the link register is containing a wrong return address due to some reason. Again usage fault will occur. Last one is unaligned memory access using multiple load store. I have told that whenever you are using multiple load store, the access will be aligned memory access. Always one word or one half word like that. Only in the aligned manner the address will be occurring. Generally it will be word oriented, STM and LDM. But if we are trying to access it in an unaligned memory access manner, usage fault will occur. Right. Then two additional usage fault can also be generated when we are performing divide by 0 or any unaligned memory access, what we have told here. Right. These are the two additional conditions. Then the same thing, if the exception handler is not enabled or if something else is running, hard fault will be executed. Right. Then again the same thing, if usage fault is occurring while a hard fault handler is running, processor will move on to lockup states. These two will be same for all the four fault conditions. Then how will you enable it? Using usage fault enable bit in the same SHCS register. System handler and state register. System handler control and state register. Then before enabling it, you need to specify the address in the vector table. All these things are same for all the four. Then these are the bits available. Divide by 0 bit, unaligned 0 bit, coprocessor bit, invalid return address, then invalid state. That means when you are trying to switch to ARM state, finally undefined instruction. So by reading the status register of corresponding fault register, status registers, you can identify which which operation has caused that particular fault condition. That is why the status register is there. Then the final one is hard fault.
Hard fault exception can be caused by usage fault, bus fault, and memory management fault if their corresponding handler is not able to be executed by the processor. It can also be caused whenever a bus fault is occurring during the vector fetch. Vector fetch means at the time of reading the address location of the exception from the vector table. Hard fault can also occur when a particular debug event is occurring. So at that time, this debug EVT bit will be set in the hard fault status register. Similarly, we have already told that hard fault can occur when a bus fault or memory management fault or usage fault is occurring and if corresponding handler is not available. So this condition will be shown by setting the forced bit in the hard fault status register. So when the forced bit is set, we can identify that hard fault has been occurred due to bus fault or memory management fault or usage fault. Similarly, there is another bit known as vector table bit. This bit will be set which indicates that hard fault has been caused due to failed vector fetch. If none of the status register bits are set, then the programmer need to check the other fault status registers to determine what type of fault has caused the hard fault. Then all the fault status bits for all FSRs, that is fault status registers, can be cleared by writing 1 to that corresponding bit. We need to write 1 in order to clear those status bits.
The faults. Whenever this fault is occurring, how can you deal with it? Generally, three methods will be followed. First one is known as reset. There is a bit known as system reset request. If we are making this bit as one, it will reset most of the reset logic. Right. All the processor and the peripherals will be reset. And if vector reset bit is set, it will be resetting only the processor alone. So you can use any of these kind of system reset request or vector reset bit. Any of this reset you can perform. This is one method of handling. Second method is recovery. Right, you can recover from that. If you are using some coprocessor instruction, additional coprocessor emulation software you can use. That means you can find out a solution for that error, that fault condition. Other than reset, you can try to avoid it, or you can correct to recover from that. And if both are not successful, another method is task termination. That task you need to stop. And if you want to restart it again, you can restart, so that sometimes it can come out of the fault condition. The FSRs retain their status until they are cleared manually. This is what we have told, right? So until you are clearing it, that bit will be set. So if you are not clearing it, always that bit will be set. You will see that that is set always. Right? That is what I told. In the interrupt also, once the interrupt is generated, you need to clear it inside the ISR. But there are certain interrupts which will be clearing the interrupt flag automatically. But if you want to avoid a mistake, whether it is set cleared automatically or not, we need to clear it manually in the ISR, even though it is cleared automatically. Right. So there will not be any problem.